How do we generate permutations and combinations? So far, we have studied formulas, ways for finding the total number of arrangements and selections in certain problems. But how do we actually list all of them? Now we're going to look into two cases. One is permutations, how we generate permutations, and the other is how we generate our combinations. Let's consider 5 elements. And here we're going to use numbers 2, 3, 4, 1, 2, 3, 4, 5. Permutations would be tuples, like 1, 2, 3, 4, 5. That's one permutation. Another would be just swapping some of these numbers, two numbers, or moving these numbers from their locations. For example, here's another one. How many are there? Well, this is permutation of five elements taken 5 at a time. So the total number would be P55, and that's 5 factorial. That would be 5 times 4 times 3 times 2. There are a total of 120 of these permutations. So that's the first case that we're going to study. And the second case would be R combinations. R combinations, we're going to consider a subset of these 5 elements. A subset with 3 elements or 4 elements or 2 elements. It doesn't make much sense to list combinations of all 5 elements because there will be only one combination. So if we talk about number of combinations of those 5 elements, then the only combination we find is just simply this one. And that's because it's, if you want to confirm that, you can simply calculate C5, 5, and that is 5 factorial divided by 5 factorial. So C55 is number of permutations, which is 5 factorial, but because we disregard the order, so we divide by 5 factorial. So this is actually 1. So listing combinations of all elements, of all 5 elements, doesn't make much sense because it's only 1. But we can talk about R combinations, which is a combination of a subset of those 5. For example, 3 combinations. So that would be subsets like 1, 2, 3, for example, or 1, 2, 4, 1, 2, 5, or 2, 4, 5. So these are called 3 combinations. So how many are there? Well, that's C5, 3. We're selecting 3 elements out of 5 elements. So the total number of 3 combinations. So that cancels with that. 4 cancels with 2. A factor of 2 is left. Total of 10. This is a total of 10 3 combinations. How do we list all of those 10 combinations? And that's what we're going to learn in this section. Okay. We can use lexicographic order. That's a dictionary order. And it's very simple. we can consider permutations as words. So we're going to establish an order. We have to have an order in order to make sure that we list all of the permutations. So we're going to consider these two permutations, and we're going to say that one permutation is less than the other if this comes before the other one when we use a dictionary order. And how do we do that? We compare entry with corresponding entry of the permutation. So we compare 1 with 1, they're the same. Now we compare 2 with 3. 2 is less than 3, so therefore this entire permutation here is less than this entire permutation. And this permutation here is greater than this permutation. That's because the first 3 entries are the same. The first 3 elements of the permutation are the same, but look at the 4th element. Here is 5 and here is 4. Therefore, this entire permutation is greater than this one. So we go from left to right until we find the first element that is different with the corresponding element from the other permutation. And if the element is greater than the other element, then the entire permutation is greater than the other permutation. That's called lexicographic order. Okay, here's let's take a look at this permutation with 7 elements. Now this permutation is less than this one. Why? Well, let's go from left to right. Here's 7, 5 is the same. Now here is 1, and here's 2. So the first element that is different, and 1 is less than 2. Therefore, the entire permutation is less than the other one. Now, we can ask the question of how do we find the successor of a permutation? So if we're trying to list the permutations, we need to know how to find the successor, what comes next, what comes after that given permutation. Well, here are 3 steps to obtain the successor of a permutation. First, you scan the permutation from right to left for entry that is less than the entry on its right. So we go from right to left, and we look for an entry of the permutation that is less than the entry on its right. So if we go here, 3, there's nothing on its right, so we keep going. 6, the entry on its right is 3. So 6 is not less than 3. So we keep going. 4 is less than 6. Now we're going to flag 4 here for a moment. And we will do something to that entry. The second step is to scan again from right to left for an entry that is greater than the element that we flagged. So again, we go from right to left. Here we go, we find 3. 3 is greater than 4, no. So we keep going. 6 is greater than 4, yes. Then we flag the second element. And the third step is to swap the 2 elements that we flagged, 4 and 6. So here they are. So we swap them. After we do that, the second element that we flagged, or now it becomes the first entry, everything after that needs to be reordered. So here we have 4, 3. We need to reorder and put 3, 4. Here it is. So that is the successor of this permutation here, of the original permutation. So let's take a look at this other example. Consider the elements 1, 3, 4, 5, 6, 7, and 9. there are 7 elements in this set here. How many arrangements of these elements are there? Well, if there are 7, then it's P77, and that's 7 factorial. And that's a total of 5,040. You can do the calculation, and it will be a lot of permutations. Okay, next, let's find the 5 first arrangements in lexicographic order. Well, the very first one is when we list all the elements in increasing order. 1, 3, 4, 5, 6, 7, and 9. That's the very first permutation or arrangement. Now, what comes next? What comes after that permutation? Well, let's scan from right to left and find the first entry that it's less than the entry on its right. We skip 9 because there is nothing on the right of 9. 7. 7 is less than 9, so we're going to flag 7. Now we scan again from right to left and we'll look for the first entry that is greater than the 7 that we flagged. That would be 9. So we swap the 2. And we swap the 2 and we reorder everything after 9. Well, there's only one element anyway, so that's 7. Okay, next, let's find the successor of this permutation. Go from right to left and find the first element that is less than the element on its right. There's nothing on the right of 7. For 9, the right of 9 here is 7, but 9 is not less than 7, so keep going. 6 is less than 9, so we're going to flag 6. Now we're going to go again from right to left, and here is the first element that is greater than 6, that's 7. So we swap those 2. Seven will go here, and then everything after 7 needs to be reordered. So after 7, we would have 9 and 6. Then we need to reorder and put 6 and 9. So that's the third arrangement. Let's do 2 more. Okay, before I write the permutation, let's use the steps. Here we go from right to left and find the first entry that is less than the entry on its right. So here's 6. That's less than 9. So now we're going to go again, scan from right to left and find the first entry that is greater than 6. That's 9. So we swap 6 and 9. One more. We go from right to left, and we find the first entry that is less than the entry on its right. There's nothing on the right of 6. To the right of 9, there's 6, but 9 is greater, so we keep going. 7 is less than 9. We flag that. Now we look for, scan again from right to left. We find the first number that is greater than 7. 6 is not greater than 7. 9 is greater than 7. We swap these 2. And then order everything after 9. After 9, we would have 7 and 6, so we reorder and put 6 and 7. So these are the 5 first arrangements in lexicographic order. All right, using the same example, the 7 elements, and we want to know now what comes after this permutation here, this arrangement. Well, let's take a look. Well, all we have to do is to find the successor. Scan from right to left and find the first entry that is less than the entry on its right. So 6 is greater than 5, 7 is greater than 6, 9 is greater than 7, 3 is greater than 9. So here it is. So we flag this 3 here. Now I scan again from right to left and find the first number that is greater than 3. That would be 5. So we swap the 2. So 3 will go here, but we have to reorder everything after 5. So that will be 3, and then next is 6, 7, and 9. So that's the successor of that. Let's take a look at this one. Scan from right to left. Here is 3 is greater than 1. Don't flag it. 4 is greater than 3. Don't flag it. 5 is greater than 4. 6 is greater than 5. 7 is less than 9. So we're going to flag that. Again, go from right to left and find the first number that is greater than 7. That will be 9. Swap the 2. So we would put 7 here, but we have to reorder everything after 9. So that would be 1, 3, 4, 5, 6, and 7. So that is the successor of this permutation. Now notice that we're finding the permutations of these 7 numbers, the original 7 numbers. So let me go back here and show you the 7 numbers. So notice that we don't have the number 2 and we don't have the number 8 there. It's only those, we're using only those 7 numbers. Now, how do we list selections of R objects from N objects? Those are called R combinations. We use the same idea. We're going to use lexicographic order, and to list all of these selections, we need to be able to find the successor of a selection. Let's consider this example, 5 elements, and we list here the numbers 1 through 5. Here's the first question. How many selections of 4 elements are there? Or how many R combinations are there of 4 elements out of those 5 elements? Here's the formula. C combination 5, 4, that gives us a total of 5. And here are all of them. Now I want to make a remark here about how do we write each combination. We need to make sure that each combination, which is a subset, we need to have all these elements in increasing order. For example, here, this combination 2, 3, 4, 5, this is the same as 3, 2, 4, 5. So both are correct answers and they represent the same R combination. However, in order to apply the lexicographic order, we need to make sure that the elements are listed in an increasing order. So this way there will be no ambiguity, there will be no confusion on how we find the successor of an R combination. Okay, so here are two of the R combinations. Now this is less than this one. Why is that? The first entry is the same. The second entry, as you can see here, 2 is less than 3. So this entire R combination is less than this R combination here. How do we find a successor? Well, here is the successor of 1, 3, 4, 5. That's 2, 3, 4, 5. Let's see the method for finding that. First, we find the rightmost entry that can be increased with an element that is not listed. If it's an R combination, then that means that not all the elements of the original set are listed there. Remember, we were working with 5 elements, and here we're listing the 4 combinations. There are only 4 elements. As you can see here from this selection here, the number 2 is missing. So we need to, the first step is to find the rightmost entry that can be increased with an element that is not listed. So 5 is the last or the rightmost entry. In the original set, there is nothing greater than 5, so we don't bother with 5. Let's move to 4. The elements that are greater than 4 is only 5, but 5 is already listed, so we don't do anything with 4. 3, the elements greater than 3 are 4 and 5, but they're already listed here, so we don't bother with that. We move on to the next entry, which is here from right to left. And this entry 1, the elements that are greater than 1 are 2, 3, 4, and 5. So the element that is not listed is 2. So we can increase this number from 1 to 2. So that's step number 2. Increase it and place the successors of the element on the right. So if I were to write a successor of this selection, I would look for the rightmost entry that can be increased with an element that is not listed. That would be 1. So I flag 1. And I can increase 1 with 2. So I put 2 here. And then everything after this number, after 2, will be listed. The successors, the natural successors from the original set. What comes after 2 in the original set is 3. And what comes after 3 would be 4 and 5. So that is the successor. Let's take a look at this example here. Consider this set of 7 numbers from 1 through 7. How many selections of 4 elements are there? That would be C7, 4. That's a total of 35 selections. What is the successor of 2, 4, 5, and 6? Well, let's apply the method. Here we go, let's scan from right to left because we want to find the rightmost number that can be increased with elements that are not listed. So 6, is there anything greater than 6 in the original set? Yes, there's 7. So we increase 6 to 7. So that's the successor. List the next few selections. So let's list the next, let's say 3 selections. We start with 7. There's nothing greater than 7, so we move on to 5. 5, there is an element greater than 5 that is not listed. That's 6. So that is going to be the new selection, 2, 4, 6. And then we list all the successors, natural successors of 6. So that would be 7. Okay, what would be the next selection? 7 cannot be increased. 6 cannot be increased because 7 is already here. 4 can be increased with 5. So it will be 2, 5. And then everything after 5 needs to be, the next 2 successors of 5 need to be listed. So that would be 6 and 7. Okay, the next successor would be 7 cannot be increased, 6 cannot be increased, 5 cannot be increased, 2 can be increased to 3. And then everything after 3 needs to be listed up to 4 total elements here. So that would be 4, 5, and 6. So we list all the successors, natural successors of 3. Let's find one more. 6 can be increased to 7. So that's the successor of that.